logs, let's write up on the above here the different log laws. Now, if you had your formula sheet, some of these are on your formula sheet, some are not. So one of them that's on your formula sheet is the product rule. What happens when we have the same logs with the same base being added? How could we write that? Do you remember? Log B, and then we AB, right? We multiply them. It's a product law. That's on your formula sheet. The other one that's on your formula sheet is the quotient law. So if they're being subtracted, what are we going to do? Divide them. So log B A over B. Okay. Another one that's on your formula sheet is the power law. The power law, we're running out of room. I hope you wrote smaller than me. Okay. The power law is if we have, let's say, a to the x, what can we do with the x? Put it in the front, right? So it's equivalent to x times log b of a. B of a. Okay. Now the ones that aren't on your formula sheet, there's change of base, we'll get to that. There's also, you can't take the log of 0. Don't know if you remember that. The log of 1 is 0. So we'll get to a couple of those. So convert each to exponential. So I'm going to set these each to x. So how do I write this in exponential form? What's my base? The little one, 8, little one, to the power of what? The power of x equals, and the inside's our answer, 64. And then it says solve it. So when we solve it, we try to make them same base. So base 8, 8 to the power of what is 64? 2, 8 squared is 64, so therefore x equals 2. So next guy, writing with exponential form, what's my base? 1/4 to the power of x equals 16. Okay, so we want to make the same base. Where could we start? Where might you start? What could you do to 16? Base 4? Sure. So we start with 1/4 to the power of x equals 4 to the power of 2. Now, is there a way we can make this a 4 to the power of something? This one, 4 to the power of, if we move it to the numerator, what happens to our exponent? Negative. So you could write this as 4 to the power of -1 to the power of x equals 4 squared. And in our power rules, power to a power, what are we going to do with those guys? Times them. Thank you. So 4 to the -x, because -1 times x is -x, equals 4 squared. So what does x equal to? -2. So you have -x equals 2. Therefore, x is -2. Lovely. Good times? Remember this stuff? No. Okay, well, this is what review's for. Oh, you need to just remember it until your diploma. Then you can forget it. Really? Okay, what law can we use here? Write an expression as a single log and then evaluate. So if we see subtraction, which one is that? Do you remember the word? Quotient. We just wrote it up above, right? That's the quotient law. And that's on your formula sheet. It is on your formula sheet. So always double check if you're stuck during your diploma. Maybe is there something on my formula sheet that can help me? So we could write this as log 6 of 108 divided by 3, which equals what? 36. And what would be our answer? 6 to the power of what equals 36? 6 to the power of what equals 36? 2. 6 to the power of 2. So our answer is 2. Okay, we can't use the product law just yet. How come? The 2 in front. You always have to get rid of any coefficient. So how can I get rid of that coefficient? Move it up to the exponent. So we can write this instead as log 4 plus log 5 to the power of 2. And now could we use the product law? Yeah, so log 4 times 5 squared, which equals 100. If we don't see the base, what is the base? 10. 10 to the power of what is 100? 2. 10 to the power of 2. So again, the answer is 2. So evaluate using a calculator. So the rule we're going to use here is change a base. And change a base is not on your formula sheet. And the formula for change a base is if you have log b of a, where b is not 10. It's not 10. It's equivalent to log a divided by log b. And that's how we're going to type it into our calculator. So log 8 of 146, what am I going to type into my calculator? Log 146 divided by log 8. Okay, so grabbing our calculators. Open. So log 146 divided by log of 8. Make sure you close your brackets for your logs. 2.4 approximately. Yes. No? Depending on your calculator that you're using. Because otherwise, it's kind of like the trig problem. Otherwise, it's taking a log, like this, think the log's inside of the log. So what this means is, if this is equal to 2.4 approximately, it means 8 to the power of 2.4 is approximately equal to 146. That's what that means. Okay, so going on, a big portion of logs, which will probably show up on your diploma, is the application questions. Yay! Okay, so make sure you know how to work with your pH formula. They'll give you the formula. You don't have to memorize it. Maybe just grab a piece of paper and a pencil for now and follow along. Okay. Where X represents, so if I was writing my diploma, one of the strategies I would use is maybe go through the highlighter. Bring highlighters with me. Highlight the important stuff. So, okay, X is the hydrogen ion concentration. And then, so they tell us that X is, and then P of X is our pH of the solution. So we know what each variable stands for. So it just says determine the pH. So we're looking for, it says determine the pH. That's our unknown. Given the hydrogen concentration is 0.05 moles per liter. So they tell us our X value, right? They tell us the hydrogen concentration. And we're looking for the pH. So negative log of our concentration. So you can just go ahead and type that in. If the base is not shown, it's 10. So you don't have, you just can type it as is. Negative log 0.005. And so our pH would be, yes.
So when it's a number, does it go log 0.05 over log?
Yes, yes, yeah. So here my pH would be 2.3. If you got a negative number, should that be an alarm that you did something wrong? Yes, pHs are not going to be negatives. Same with your numerical response. Numerical responses are not negative numbers. So if you get one or you get a decimal that won't fit, like they said to the nearest tenth and you get this number, that's not going to fit into a numerical response. If they said 1 decimal place. If it's 1 decimal place, it's either going to be like that or like that, right? So those should be cues to you. I did something wrong. Let me try this again. Okay? Don't try and force something to fit. Okay, it won't fit. They're not going to do that to you. I'm just going to squeeze it in here. Okay, determine the concentration of hydrogen ions in distilled water with a pH of 0.7. So this time, they gave us our pH. So if my formula is P of x equals negative log of x, negative log, what are we going to substitute? Which variable? P of x. P of x. So give us the pH, which is P of x. So 7 is equal to negative log of x. Okay, now we actually have to do some work to solve. Whenever you're looking for the inside of a log, eventually you're going to have to change it back to exponential form. Okay, so what's our first step? Yes, Leah. Take a guess. Okay, before we can change it to exponential form, what do you have to get rid of? The negative. The negative. Can't have anything in front of the log ever before you change when you change it to exponential. So how do I get rid of the negative? Move it to the other side. Divide by negative 1, essentially. Negative 7 equals log x. Now can we change it to exponential? 10 to the power of negative 7, right? Our base is 10 if you don't see it. It's an imaginary 10. So 10 to the power of negative 7 equals x. And in our calculators, that gives us a small number. 1 times 10 to the negative 7 moles per liter. Really, really, really tiny. Okay. Black coffee has a pH of 5 and bleach has a pH of 13. In terms of hydrogen ion concentrations, how much more acidic is black coffee compared to bleach? Does anyone remember how we solved this? If you wanted the intensity of something. So we know on the scale, so you could use your scale, yeah. You could actually, one way you could solve this is we have 1, 2, 3, 4, 5, 6, 7, 8. I'm running out of room. 10, 11, 12, and 13. So one way is we're comparing 5 to 13. And how many spaces is it? 1, 2, 6, 7, 8. Now, would it be 8 times more intense? Or how many times more each space? Times 10. So this would be times, well, the 5 is more intense than the 13, right? Times 10 each way, going this direction. So times 10 more acidic, times 10 times 10. Because this is the acidic side, and this is basic. And so it would be 10 to the power of 8. Okay, so you could figure it out just actually drawing it. The other way you could figure out, which is not on your formula sheet, is using the idea of intensity over 1 over 2. Yes? What do you mean? I wouldn't trust that they'll explain that. They might. They might explain it, but I would say you're going to have either a pH, an earthquake, or a decibel question. Be able to solve those, right? I gave you, like I would just almost memorize it so I'm really comfortable with that because it's going to show up. And then you don't have to rely on their explanation, but you just go in prepared, okay? So it was 10 to the pH 2 minus pH 1, I believe it was. Like this is, we're comparing 5 to 13. Yeah, so if we're comparing the 5 to the 13, we take the larger, right, the 13 minus the 5, which gives you the 8. Same idea. Okay, so you could memorize this formula. They probably won't give you that one. Okay, otherwise you can draw it out and figure it out from there. It's hard to draw it out and figure it out if they're decimals. Then you really do have to use the subtraction, right? Only if they're the whole numbers could we use just the subtraction method. Fun, 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 fun. Okay. Exponential. A lot of you had fun with this. Some of you had fun with this maybe. When we solved these guys, we had to make the same base. So how can we make them the same base? What would be my first step? 49. Okay, 49 you could change to what? So 1 over 7 power of 2. You should probably know your perfect squares. I would say. Be a good thing to know at this point, right? Okay, now what can we do? How do we bring the 7 up? Those are good old days, hey? Simpler times. How do we bring the 7 squared up? Make the exponent negative. Okay, now what do we do? Okay, distributive law here. Don't forget to miss its distributive law, so you need to multiply by both of them. Okay. So we have 7 to the power of x equals 7 to the power of negative 2x plus, no, not plus, what? Minus 6. And now that our bases are the same, what can we conclude? X equal, we can set our exponents to be equal and solve for x. So now solve for x here. Okay, so what's your first step? Plus 2. So we get 3x equals negative 6. Therefore, x is negative 2. Okay? And then you could check your answer from there. Now, what do we do when we can't make the bases the same? Does anyone remember? It's been a little while, not too long. That's when we have to use, starts with an L, ends with a G, logs. What did you say? Okay, logs. So when you can't make the bases the same, we're going to take the log of both sides. So I'm going to write log 3 equals log 8 to the power of 2x minus 1. Is it coming back to you? Sort of. A little bit. Yeah. Okay, so now what I have to do? We want to solve for x. So being in the exponent is not a good place. So we're going to use the power law to bring it down in the front. Remember? There you go. Remember, this has to be in brackets, though, our exponent. If it's more than one thing, has to be in brackets. Very, 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 very important. Okay, what could you do next? There's a few options. Divide by, yeah, we can divide by log 8 right now if you want. We could also distribute it in, but I think it'd be easier if we divide by log 8. And if you want, you could even type that in your calculator. Get a decimal. So log 3 divided by log 8. Close the brackets. Bracket. Bracket. 0.528. So 0.528 equals 2x minus 1. And now it's just simple algebra. I hope. Right? I always hope. Sometimes when you get stressed, the easiest things become the hardest things, right? When you're under pressure. Not if you're clutch. Divide by 2. So in our calculator, we can just go plus 1, keep the exact value, and then divide by 2. And there's our answer, 0.764 equals x. Boom. Done. Okay. Wakey. I'm so tired. Kaisa. I think that's how you pronounce it, actually. Seriously. You think Kaisa? No, but I know somebody who spelled her name like that. No, did she have an S? She did. So it's Kaya? Kaya? That's a pretty name. Yeah. It's unique, hey? Kaya? Do you know any Kayas? I don't. You do? I like it. Sweet. Okay, so Kaya invested $8,000 in an account that pays 6% compounded monthly for the next 5 years. Which formula is this one? Which formula is this? The investment one. A equals P times 1 plus I over N to the power of, I is your interest rate, or R over N. Did we do R? Okay, R over N, sorry, times the power of NT. NT. Good times? On your formula sheet, what's on your formula sheet? Someone have one other formula? I don't think it's on there. Where's your blue book? Is your formula sheet on your blue book? Front page. Oh, is it? For sure? No. Someone have their formula sheet on them? Green one. Oh, green one. I don't think that's on there. No. You got to know this one. Eek. So, ma'am or Isaac. Yes. Yes, they do. I will. You're better than that. If you cheat on a diploma, it is a big deal. Like, you get a 0, like writing on your hand, little notes, whatever. It's a big deal. Why? He did on his diploma? That's horrible. Okay. Hey, stop giving them ideas. Okay. So how much, so P, what's P? That's our investment, principal investment. So how much did we invest? 8,000. 1 plus, we have to do what to our percent? Decimal. So what is it as a decimal? 0.06. Remember, percent, cent stands for like century, 100, per 100. 6 per 100, 6 over 100. Divided by, how many compounds a year do we have? 12, because it's monthly. The power of, oops, that's a different type of bracket. I hate that. It makes me feel uncomfortable. Sorry. No, it's just not right. To the power of the total number of compounds. How do we get that? 5 times 12. Total of 60. So in our calculators, 8,000. 1 plus 0.06 divided by 12. Now, if you're going to do the multiplication in the exponent, then you have to have brackets there. If you just put 60, you don't need the brackets. So 5 times 12, and we invest, that's how much total. So 10,790 and 80 cents. So about $2,000. Well, 2,700 actually, almost 2,800. 10 grand, yeah? Isn't that what, but I said how much did he earn? She earned though. 27, yeah. Determine how much money there'll be in her account after 30 months. So this is what you have to be careful of. So this time, the only thing that changes is the number of compounds. So if it's 30 months, what is my exponent? If it's compounded monthly for 30 months, how many compounds do we have? 30. Okay, we don't have to go years times number of compounds a year because they tell us it's in months and they tell us it's 30 months. So there's 30 compounds. Okay, in this case. So same idea, except for our exponent is 30. So 9,291 and 20 cents. In which month will Kaisa have 20,000? So how do we set up the problem? What do we know this time? A. We know A. 12,000. Then you divide by 8,000. Right. So 1 plus 0.06 over 12. And we'll just say to the power of x, because x is the number of compounds. And since it's monthly, that will give us the number of months. So first step is what Andrew said, is we want to get the base by itself, just like how we get the log by itself. And so get rid of the 8,000 by dividing by 8,000. This is 1.5. That's a nice number. Equals 0.06 divided by 12. Let's simplify our base. So 1 plus 0.06 over 12. 1.005. Power of x. So now, can we make these bases the same? No. So what do we have to do? Log of both sides. Log 1.5 equals log 1.000. Whoop. Getting carried away with my zeros. Don't we all? Now what? Move the x to the front. Power law. And then we want x by itself, so divide both sides by log 1.005. Yeah, so you can see how even though there's 40 questions, one question like this is going to take some time. Log 1.5 divided by mostly not. Last semester, it was so tough, right? Like the average was 53. We had 33% fail. And often they make semester 1 and 2 exam at the exact same time. That's how they do it. Rational expressions. There was 8 on the last diploma. Yeah, there are 8. So, how many months? What did the question say? In which month will she have at least 12,000? I only get to see it once you're writing it. I'm not allowed to be in the gym. Okay, so how many months? If it's 81.3, at 81 will she have 12,000 in her account? No, be just below. So she needs to go to the 82nd month. So 82 months equals x. If it was years, then we'd have to divide that by 60. Okay. Yeah, we're almost done. Same idea here. Let's look at. Okay, let's go on. E. coli is a bacterium that lives in the intestines of mammals or humans. Yeah, it could be humans too, right? It does damage to you. Lots. Okay, so they're giving us some information, and they've already actually made the equation for us. Okay, Predict how many bacteria there will be in a sample of 12 minutes. So we want to, okay, X represents the number of minutes, and Y represents the number of E. coli. It's important to know which one's which. So if we have 12 minutes, which variable is that? X. 12 over 24. What do you have to be careful of when you type this in your calculator? Brackets. Especially around where? Your exponent. Who? Me? I do this every day. Since like I was your age. So how many E. coli to the nearest E. coli? 283. Predict how long. So what if it says how long? Which variable is this? X. X is our time. So find X in minutes. If they give us how many E. coli, this is Y. Now, there's another way we can solve this instead of using logs. What's the other way? Graphing it. Okay, so let's try graphing this one. So grab your calculators or just follow along. So what would I put, how would I graph this? What would I put in my equations? The first one would be y1. Thank you. Second would be y2. And what are we going to find? The intersection. Now, the only toughest thing about doing it graphically is what? The windows. You guys usually, most people struggle with that part. And you also need to remember your brackets. So your exponent has to be in brackets here. It's very important, else you won't get the right thing. You could try Zoom Fit. Have you ever tried Zoom Fit to give you a starting place? So Zoom number, I think it's 9 or 0, mine. And it gives you a starting place. And then you just zoom out from there. Ooh. Okay, let's zoom out from there. That's not really giving us anything. We might have to make our own windows, folks. Now, if you know this is your Y1, you know this is how high you need to go, right? You can use some logic. So I can go back to my windows and say, okay, let's use some logic here. Let's go my Y first. I need to go to at least 204,800. Let's go above that, though. So maybe 300,000. And I'll go, that's my scale. My X, what's X in? What's the variable talking about? I just don't like so many ticks. I'd actually probably add an extra 0 in there. You don't have to. You can leave it as 1. It's just a real solid line, right? It's ugly otherwise. Now, you can have negative time. So X is in time, minutes. Are we going to get like up to this many minutes? Probably not. So we can try even up to 200 minutes, especially with they're giving us like 12 minutes in this one, right? So let's try up to 200 and see how that goes. Scale of 20 maybe. Okay, we did a better job than they did, I think. Well, except for we need to go add more minutes. We're almost there. So we'll go back to our X, maybe go up to 500. So use this Y1, right, as your Y scale. Help that with your Y. So second calc, 5, enter, enter, enter. Oops. What did I do? Oh. I know, hey? Where's the undo button when you need it? Second trace, 5 for intersection. We get, there you go, 240. So X equals 240. Okay, so, I mean, you could do it that way or algebraically. Both would work. No, you have to get rid of the, oh, so then you would do, in the end, you'd still go X over 24. You bring that down in front, and then you could times both sides by 24 to get rid of that. Okay, so we graphed things. We graphed exponential functions in the form of ab to the power of x. Does anyone remember what the a value represented? Or even what the curve looked like? Do you remember what an exponential graph looked like? Yes, like this. Or that was a growth. Or like this, decay. Okay, so what's the a value? Does anyone remember the a value? Nope. The y-intercept. So a was your y-intercept. Okay, and b was your base. It tells you how fast it's whether if it's growth or decay. How do we know if it's a growth function? What would be above 1? So it's if b is greater than 1, it's a growth. If it's or we won't have equal to 1 to the power of anything. It wouldn't be actually an exponential function if b is 1. Because 1 to the power of anything is 1. So then it's just a straight line. It's a decay if it's between 0 and it's greater than. B is, yeah. No, I did that wrong. B is greater than 0 and less than 1. It's a decay. So usually a fraction or a decimal, right, as long as that fraction or decimal was less than 1, is a decay function. So use equations to predict, each equation to predict the x-intercept, number of y-intercepts, the end behavior, the domain, the range, and so forth. So here, yeah? No, we didn't. No. We have negative, maybe it's logs, but not with exponential. Okay. So also with this graph, the x-intercept for exponential, did it ever touch the x-axis? No, it actually got closer and closer, but it never touched. So was there an x-intercept? None. What's the y-intercept? 125. 125. Would this be, so end behavior, how would you say your end behavior was? If this is quadrant 1, 2, 3, 4. No, I did that wrong. Silly me. 1, 2, 3, 4. Sorry. So it goes from 2 to 1. And then domain of this function, forever left and right would be XER, and range of the any exponential function greater than 0. Y is greater than 0. Can't touch 0. All right, we're almost at our limit for time. Log functions looked a little different. Okay, so a log function, there was growth and then there was decay as well. Now the difference was if you had a growth, it looked like this. Remember, it's the inverse of an exponential reflected in y equals x. If it was a decay, I'll use black, it looked like this. Okay. If our a value was positive, it was a growth. So this one, if a, this is our a. It was a growth. If a was negative, it was a decay. Right? So for a log function, if a is greater than 0, it's a growth. A is less than 0, decay. So this guy, the x-intercept always went through 1. Okay? It wasn't the a value. So x-intercept would be 1 on all log graphs. Would there be a y-intercept? No. How about end behavior? For this guy, it's a growth, so it would be 4, 2, 1. And then domain, x is greater than 0. Never touched an asymptote here. Y equals 0. And then range, could you go, is there any restrictions or what would it be? Y-E-R. Forever up and down. Where does that bring us? Okay, regression equations. Let's see, how much time do we have? The bell's gonna go? Okay. All right, so you can start the practice for homework. I'm gonna leave it here. I know it's a long class. Look how much recording we did.